Earth materials. Look at these three pictures of very diverse rocks in the images below. How are they different? How are they alike? Which Earth systems created these materials? What processes work to recycle the rock materials on Earth? Where does all the energy needed for these processes come from? Eroded basalt rock along the beach of Washington, folded Genesis rock in the Arizona mountain, weathered sandstone arches in Utah. The black basalt along the beach is usually an eroded lava flow from an ancient volcano. Basalt is classified as igneous rock because it is formed from molten magma. Genesis rock was formed from buried rock layers, remelted and cooled, resulting in bands of minerals that have been folded. Genesis is classified as metamorphic rock because existing rock has changed due to tremendous underground heat and pressure. Sandstone, a type of sedimentary rock, was formed from sediments collected at the bottom of ancient rivers or seas that were buried and become solidified. Later, the area was uplifted and exposed to sandstone. The sandstone was eroded repeatedly by winds that sculpted the formation into arches and openings you see today. The story of these three rock types is the story of our Earth and consistent recycling of materials above and below its surface through the interaction of four major systems on Earth: the geosphere, the rocky lithosphere, the atmosphere, air, the hydrosphere, water and ice, and the biosphere, living things. All the Earth's processes are the result of energy flowing and matter cycling among the planet's systems. This energy is derived from the sun and the Earth's hot interior. The energy that flows and the matter that cycles produce chemical and physical changes in the Earth's materials and living organisms. What do you think? The rock cycle. Geologists classify rocks into three categories: sedimentary, igneous, and metamorphic. How do you think the three major rock types are formed? Rocks are separated into these three types based on how they are made. Sedimentary rocks come from erosion, deposition, and cementation of sediments laid down at the bottom of bodies of water, such as a riverbed, lake bed, or ocean floor. Igneous rocks form from the melting and cooling, the crystallization of magma, lava, or other rocks that were melted deep within the earth. Metamorphic rocks are pre-existing rocks that have changed due to heat and pressure. When rocks undergo additional processes, they can change from one type of rock to another. Depending on the processes, any type of rock can become any of the other types. It could even become a new rock of the same type. For example, a sedimentary rock could become a metamorphic rock, an igneous rock, or a new type of sedimentary rock. This depends on what happens to it. The process by which the rocks change into new rocks make up the rock cycle. Remember, energy from the sun and the Earth's hot interior drives the process in the rock cycle. So here is the rock cycle depicted. We have sedimentary rock, igneous rock, and metamorphic rock. You have sedimentary rock, the melting and cooling. You have changing temperature and pressure. You have melting and cooling. You have erosion, deposition, or cementation. You have changing temperature and pressure. You have erosion and deposition and cementation. Reflect. Igneous rocks. Igneous rocks are formed when lava or magma cools and solidifies. This solidification is known as crystallization. Molten rock under Earth's surface is called magma. When magma reaches the surface, it is called lava. Igneous rocks have interlocking mineral crystals that vary in size depending on how rapidly they cooled. When magma cools slowly under the Earth's surface due to high temperatures, the mineral crystals grow very large. Igneous rocks that cool slowly under the Earth's surface are known as intrusive igneous rocks. Okay, so this image shown is a magma chamber, and then this is showing the intrusive igneous rocks, and then extrusive igneous rocks. Okay, and then we have another image, so we have intrusive igneous rocks on the left and on the right. When lava cools on Earth's surface, it solidifies very quickly, resulting in small crystals. Sometimes no crystals will form at all. In that case, the rock will have the characteristics of glass. One example is obsidian, shown below. A volcano may shoot blobs of lava into the air. These blobs have many air bubbles like pumice, shown below. They cool so quickly that they solidify before they hit the ground. Lava that oozes out and cools can form a black rock called basalt, shown below. Igneous rocks that cool quickly on or above the Earth's surface are known as extrusive igneous rocks. To remember the concept, think of external when considering extrusive igneous rocks. Extrusive igneous rocks form on the Earth's surface. What do you think? Sedimentary rock formation. Where do you think all the sediments that form sedimentary rocks come from? Weathering. Rocks can be broken down by forces on the Earth in a process called weathering. Once rocks are broken down, the smaller pieces are called sediments. The weathered pieces can form anywhere you find rocks, such as mountains, plains, valleys, etc. Erosion. Sediments can be carried from place to place. This process is called erosion. Erosion carries sediments through the wind, water, gravity, or other means. For example, sediments can travel downstream in a river or can roll downhill in a landslide. Deposition. Eventually, sediments stop moving and settle into layers on the bottom of the rivers, lakes, or oceans. This process is called deposition. Compaction and cementation. New layers of sediment build up slowly over time, pressing down on the layers below. Dissolved minerals such as calcite and silica cement the grains together. In time, compaction and cementation lead to the formation of sedimentary rock, such as sandstone or conglomerate. These hills are made of sedimentary rock called sandstone. Sandstone was deposited underwater, one layer on top of another, before all the layers of rock were compacted and cemented together. This area was eventually uplifted, and after many years, weathering and erosion have exposed the formation visible today. The rock cycle is continuous. Look out! Not all sedimentary rocks form from the pressure of compacting sediments. When minerals come out of the solution and settle in the ocean floor, a chemical sedimentary rock forms. Gypsum on the left is an example of a chemical sedimentary rock. Organic sedimentary rocks, such as limestone on the right, form from the remains of living things. What do you think? Metamorphic rocks. When rocks are buried deep in the Earth's crust, heat and pressure can cause the buried rocks to change into new rocks. These are called metamorphic rocks. Metamorphic rocks start out as some other kind of rock, such as sedimentary, igneous, or even other metamorphic rocks. Rocks get buried under tremendous heat and pressure from the layers on top of them. This compacts existing rocks. Heat and pressure can change the grain size and even the minerals that make up those rocks, producing new types of rocks in a process called metamorphism. So this image is showing you the process of metamorphic rocks forming, heat and pressure. One physical change, foliation, is caused by extreme pressure applied to the rock from just one direction. This forms alternating bands of different colored crystals. Genesis is an example of foliated metamorphic rock that is formed from banded sandstone. Metamorphic rocks are often characterized by bands or wavy layers of mineral crystals or by the presence of unusual minerals. Chemical changes can also occur during metamorphism. Under the heat and pressure, mud that is compressed into shale, a sedimentary rock, changes to slate, a metamorphic rock. So these are metamorphic rocks formed under heat and pressure from existing rocks. So granite changes into Genesis, shale changes into slate, limestone changes into marble.